Day 24, Crossed Wires. You and the historians arrive at the edge of a large grove somewhere in the jungle. After the last incident, the elves installed a small device that monitors the fruit. While the historians search the grove, one of them asks you if you could take a look at the monitoring device. Apparently, it's been malfunctioning recently. Okay. The device seems to be trying to produce a number through some Boolean logic gates. Hey, already off to a good start. I love these. Each gate has 2 inputs and 1 output. Okay, the gates all operate on values that are either true or false. Okay, 1 or 0, simple. AND gates, output 1 if both inputs are 1, if either 0 or both are 0. Okay, so these are just AND or an XOR, I'm guessing. If 1 or both inputs is 1, if both inputs are 0, then they're 0. Cool, XOR if the outputs are different. Okay, so there's nothing tricky. These are just literally AND or an XOR. Cool. You can build a lot of fun stuff with AND or an XOR gates. Gates wait until both inputs are received before producing output. Wires can carry 0, 1, or no value at all. Oh, okay. So not like floating, they literally just have no value. Okay. There are no loops. Once a gate has determined its output, the output will not change until the whole system is reset. Oh, nice. Each wire is connected to at most 1 gate output, but can be connected to many gate inputs. Okay, that makes sense. Rather than risk getting shocked while tinkering with the live system, you write down all of the gate connections and initial wire values, your puzzle inputs, so you can consider them in relative safety. For example, okay, x001. Okay, so these are like the default value. These are the initial values. And then we can see that if you AND x00 and y00 together, you get what z00 is. If you XOR these two, you get z01. And if you XOR these two, you get z02. Okay, I mean, this input seems very simple. Because gates wait for input, some wires need to start with a value as inputs to the entire system. The first section specifies these values. For example, this means that the wire named x00 starts with the value of 1. Cool. Awesome. This is super simple. The second list lists all of the gates and the wires connected to them. For example, x00 and y00 will yield z00. So an AND gate, which has wires x and y connected to it, and will write its output to z. Cool. Awesome. Simple enough. In this example, simulating these gates eventually caused 0 to appear on wire Z0, 0 to appear on wire Z1, and 1 to appear on Z2. Okay. Ultimately, the system is trying to produce a number by combining the bits on all wires starting with Z. Z00 is the least significant bit, then Z01 and Z02. Okay, so Z00 is the least significant. So this would be 1, 0, 0. The number it produced would be 1, 0, 0. In this example, the 3 outputs from the binary number would be 1, 0, 0. Okay, yeah, cool. Here's a larger example. Oh yeah, oh boy. Okay, okay, big example. After waiting for values on all wires starting with Z, the wires in the system have the following values. Okay. Combining the bits from all wires starting with Z produce the binary number this, converting the decimal gives you 2024. Okay. Simulate the system of gates and wires. What decimal number does it output on the wire starting with Z? Okay, this doesn't seem too bad. This starts at Z00 and ends at Z12. I assume they'll always be contiguous, the numbering, and there won't be any gaps between it, just because Eric doesn't seem to throw in any sort of curveballs like that, but we can double check that and make sure that's the case. But I would say, yeah, let's go ahead and get started with this. So what do we have here? CD into 2024, make dir day 24. Awesome. Let's vim simple.txt. Simple is the, because there were 2 examples they gave us. They gave us the simple example, which is this. And then we have the example input.txt. This is the bigger example. I'm just going with the same naming that we've been using before. Cool. This looks easy enough. And then real input.txt. I'm going to go grab the real input now, which is specifically for me. Oh yeah, there's a lot of stuff in here, but it's not, the real input's not crazy long, which is nice. There's a lot of stuff in it, but it's not crazy. Cool, let me share my terminal. Awesome. Let's do a word count -L of everything here. Okay, the simple example has 10 lines. The, oh, that's distracting. The example has 47 lines, and the real input has 313. Okay, cool. this doesn't seem like it will be that bad. So here's what I'm thinking. We have values. Let's think in terms of data structures now. We're going to have an associative array of values, which will store the name of the wire and the output it's producing. This can be 0, 1, or it'll be unset, so it'll be nothing by default. We'll go through and we'll load all the initial values here. Okay, we're going to have a bunch of different wire names here. We should have another associative array called inputs, and this will literally just be like an array of all the wire names. So we'll just keep track of every single wire we've ever seen. Not whether we have it set, not how to calculate it, we'll just keep track of the names in a deduplicated set. Okay, so we have an array for values, an array for every single wire we've ever seen, and then we need a third array called like calculations or equations or something, where that array will store how we calculate it. So in that array, we'll have something like Z05. The value of that, the key will be Z05. The value will be this and that. So KWQ or this. So we can look for every, here's what we'll do. We'll go through the list of every single wire that we have. We'll check, hey, do we have a value for this? If so, great, skip it. If we don't have a value, check to see if the 2 in the equation have a value, because if they do, we can calculate its value. So we'll go from top to bottom in this list, and we'll try to get a value for every one, and we'll get some along the way, and then we just repeat that. And we repeat it, and we keep doing it until eventually they all have values. Yeah, this is straightforward. There are more performant ways to do this, because all we care about is the Z values. Technically, there could be things in here we don't care about. We could start with each Z value and then kind of work our way backwards and recursing through this and figuring out, okay, you know, we need QHW. What does QHW need? QHW needs something else. Okay, and keep going until we solve it for that. But I'm not too worried about that kind of solution. Let's just write some basic code that can read that in and parse what we have. Simple bash script. We'll do a, yeah, what's up, Zenith? How you doing? While read -r line do echo line. The nice thing is there are blank lines. Yeah, what's up, Darkspace? How you doing, man? Nice. There are blank lines here, so we can read until we hit a blank line, and then we know we're onto the second section of the input. Yo, what's up, J Squared? You know what? I gotta understand that even if my audience isn't talking, they're chilling here, which is nice. It's nice to see you guys. All right, let's see. So we can say -n line, meaning there is something in that variable, or we break out of the loop. So read the initial values, read the gates. We'll call them gates. Read the gates. Cool. So what are you coding? I'm coding Bash right now. I'm working on a series of puzzles called Advent of Code. I'm on day 24 of Advent of Code 2024. So I am coding something to simulate logic gates. And I will say, based on this puzzle, we have ANDs, we have ORs, and we have XORs, and we are producing a binary number. I've done logic gate stuff before. I've seen half adders and full adders. So my brain's already thinking that. We'll see if that's relevant, but so far in part 1, it's not even relevant what kind of circuit we're doing. We just need to simulate it. So we'll see what happens here. So if we do this and we pipe it to part 1, we should get the same exact output, but without a new line between them. And that's exactly what we get. So now for this one, we have a wire name and a value. The wire name technically has a colon in it, so we have to get rid of that. Wire equals wire %colon, and so we'll get rid of the colon that's at the end of the line. That might be confusing, but we can say wire equals value. And now when we run it, you can see, okay, here's the name of the wire, and here's what its initial value is. So this is cool. We can work with this because we can do a couple things here. Declare -a values. This will be our array of all the values after the wires have settled. Wires. This is every single wire we have ever seen. We don't even care. We're just storing it. We're storing it in a deduplicated set of every single wire we have seen. And declare -a. I'm trying to think of what to call this one. We could call it gates, but it's not really a gate. It's a way to determine how to calculate it. So we can call it like, I don't know, equation, for lack of a better term. And I'll explain what we're going to use these three arrays for. Once we see a wire here, we should keep track of it because this is a wire scene. And once we have this, we know a value for it. Values, we can initialize the value of it to whatever the value is, which will be either a 0 or a 1. Cool. Now we're going to read the gates. So let's do a couple things here. We're going to pull in from day 23. Of course we are, my var dump function, because it's so useful just to be able to say var dump wires and var dump values. So now let's go ahead and rerun this. I didn't source it. There we go, now it's sourced. So this is a list of all the wires. The keys are really what we care about. They're just set to one, that's arbitrary, that could be anything there. We're gonna get the keys from this. And these are the initial set of values. This array will grow as we resolve more of the equations. More of the equations. We should use S's everywhere. Cool, so now we have to read the gate equations. And that looks like cat example tail -1 name operator name. So A operator, B, and then the key that it yields. Okay, so we can do this. We can say left-hand sign operator, right-hand sign throwaway variable because it's a picture of an arrow, and then the wire. So what that means is we can say wire equals left-hand sign operator right hand side. So when we print this out, you'll see what it looks like. That's not what I wanted to run. This is what we have. In order to calculate z00, we need x00 ANDed with y00. We need this XORed with that, and we need this XORed or ORed with that. Okay, this is not bad because now we can store it in the equations. Equations wire equals, and we'll just do the exact same string, op right hand string or right hand side. Cool. And then wires equal 1. So again, we're keeping track of all the wires we have seen. So once we get down here, we can know that echo, we found blank total wires, echo values have initial values set. So cool. So this will go through and it will tell us we found 9 total wires. So in our simple input, there are 9 distinct wires. There are 3 X's, 3 Y's, and 3 Z's. So that's 9. And let's see, 6 have initial values set. Yo, what's up, Andre? How's it going? Don't worry, I just got started. We are just jumping into it, but I kind of jumped into this one fast because this one is very, this one, I like this one. I like logic gates. I'm totally ready for how to process this one. I'm very excited for this one. This one's very straightforward. I'm afraid of what part 2 is going to look like, but part 1 for day 24 so far, really approachable. We found 9 total wires, 6 have initial values set, so we should have 6 initial values here and 9 total wires. That looks great. So now what we can do, step through the list of wires and try to resolve as many as we can. We will do this in a loop until we are fully done, and we will figure out what that looks like, but we're not there yet. I think I saw someone or some people doing it by hand on the subreddit. That's impressive. That's actually impressive. It's so funny doing it by hand, dude. I could imagine someone busting out a breadboard and just doing it. That'd be fun to see. Because it's only and, ors, and XORs. Very simple instructions. So let's see. Let's see. We need to loop over every single wire and see if it has a value set. So for wire in wires, and again, this is a associative array, so we just need to loop the keys of it. That's all the possible wires we've ever seen. We will check value equals if it has a value, set, then we don't need to do anything about this. Value already resolved. Skip this one. Cool. If we don't have a value set, try to solve it. What we will do is we will get the equation from it. Cool. And then we will break it into its parts, which are the left-hand side, the operation, and the right-hand side. And then we will say echo trying to solve wire, left-hand side, op, right-hand side. This is just for our own testing, just to make sure that we do things properly. And we're not doing things properly. We have a nice little syntax error because I didn't put for in. Cool. So we have 9 total wires, 6 have initial value set. We skipped over the ones we don't care about, and we are trying to solve 0 and 1. In order to do that, we need x0, 1 and y0, 1. So now we have to look to see if those exist. Okay. So we can do left-hand value equals values at left-hand side. Right-hand value is the values at right-hand side. If dash n left-hand value and that means if they're set. Doesn't matter if they're 1 or 0, just if they're set. If we have both these, then yay, we can solve this wire. Then we will do this. We will say case operator in, and there are 3 possible operators. We have and, or, and XOR. So if they're and, then the result is left-hand value and right-hand value. These are commutative, so we don't have to worry about the order of them. If they're or, then we logically or them. And if they're XOR, then we logically XOR them. We store them in something called result. And then we can say values at wire equal result. And that's what we will do. So this will step through and do it once. Now we need to do this in an infinite loop. Almost infinite. We'll figure out what that looks like. While true, do. Done. Why didn't these get... There we go. Okay. So when we're here, we'll set keep when do we know when do we break out of here? We break out of here when every single one is set. So we have to know that every single one made it here, or we can check if we've made it down here. We could say keep going equals true. And at the top of this, we could say keep going equals false. We need a do while loop, but it's fine. While keep going, we'll just keep doing this loop, and we'll set keep going to true to initialize it. We'll initialize it as true. And then this will just run. Echo trying iteration I. Let's do I equals 0. Down here we'll do I plus plus. There we go. Go. We are done. All values are set. Let's get an idea of how this runs. Okay. So we tried one single iteration. We tried iteration 0. We tried 2 iterations. Yeah. The 0th one solved Z01, Z00, and Z02. And then in order to break out of the loop, we checked there was no reason to keep going, so we checked all the values again. They were all set, so we are done. We're basically there. Like basically there. If I run this against the example, okay, the example works. we need to figure out how many z's there are. Find all of the z values in order and calculate their binary representation. Okay, it's easy. We might have to sort these z variables. Unless the puzzle promises us that unless the puzzle promises us that all of the z variables are contiguous, otherwise we'd have to calculate like a min and max or something, or we'd have to go through and sort them. Let's see. I'm going to try this. I'm going to loop all of the values we've seen. The names of the values we've seen at the end. Okay. And then I'm going to pipe this whole output to sort. And let's see. Z0 all the way up to Z12. I think they're going to be contiguous. I don't think we have to worry about that. If I do the real input. Yeah. It goes in order. Z0 all the way up to Z45. So we don't actually technically need to sort it. we can cheat here. We can find the lowest Z and the highest Z. That's totally what we can do. It's so stupid, but we can totally do that here. Yeah. While we're here, let's find the highest and lowest Z. I'm sure the lowest will always be 0, but like, who cares? Min Z equals just empty. Max Z equals if wire is equal to Z star, then get the number part of it, which is the wire without the Z at the beginning. If dash Z min Z or num is less than min Z, M-N-Z-Y, min Z equals num. Yeah, that's the logic we want. And then we just change this to max Z. If num is greater than max Z, then max Z equals num. We found total wires, blank have initial value set, equal min Z equals min Z, max Z equals max Z. My Z button's being really weird. Oh, I got like stuck for a second. We're good. So now if we run this, let's do the simple one again. Min Z is 0, 0, max Z is 0, 2. Okay, that's cool. We may have to force them to act like base 10. Which, I mean, this just seems silly, but it's okay. For I equals, can we do this? I less than or equal to, I'm trying to force these variables into base 10. I think this works. Value is too great. Is that right? Okay, that might be the way to do it. Part 1, read in from the example input. Okay, and if we read in from the real input, we get that. Okay, cool. So that's correct. That's how you do it. That's so strange. So now we need to create a binary string of all of the bits in the value at that Z location. So we can do it like this. Wire equals Z I. Oh, right. We might have to pad it with zeros. Yeah, let's just pad it with zeros. Printf dash V wire. Now we can say %20D, I think. Yeah, is that how you pad it with zeros? We'll see. Hi. And then we'll just echo wire. Oh, that made it 20D. 02D. There we go. So that put leading zeros in front of it using printf. Can you just OR at the specific value in bash, or is that not a thing? Can I just OR at the specific value in bash? I'm not sure what you mean by that. Like we have an OR operator here, you know, like the pipe character. Like here's where I do the actual operations, but I'm not sure what you mean by that specifically. So now we have the value. Let's get the value at that wire. Value equals values at wire. And we can make a nice little representation of this string. There's a couple ways we could do it. I think just treating it like a string is probably fine. And we can just push these bits. We're starting at 0. Which one's 0? 0, the least significant bit? I think they said that zeros were the least significant bit of the output one. 0 is the least significant bit. Okay, so they have to... We push at the beginning. Okay. So then we just say S equals S value. Echo final is S. Let's see if this works. Well, didn't quite do anything. Oh, the wire has a Z in front of it. Okay. So according to this, our simple input, the answer should be 4. Oh, do they want us to convert it to... Oh, to decimal at the end. Okay. So this one's 4. The next one should be 2024. So let's do this. We have to... Yo, what's up, Tablet Nova? How you doing? Now that we have this giant binary string, we just need to convert it to decimal. I do see you have OR. So if Z01 is set, you can just OR the output with 2 to the 1. No, don't have to go through a string. It's true. You could totally do that. I could build up a string and I could shift it and constantly be ORing it on. I could OR it at that location in the string. Yeah, there's a ton of stuff you could do here instead of having to treat it like a string. But I'm taking the math or the non-math version, just doing it all in strings, because at the end of the day, everything to bash is like a big giant string. So now we need to turn this into decimal. Is there an easy way to do that? Let me remember. Can I just do this? There's no like %B, right? Oh my god, no, that's not right. What am I thinking of? No, that might just be treating it as bytes. I think we wrote this code before, didn't we? I know I can use the BC command to do it. Hello, Basher Man. Finally got some free time from uni to watch you stream again. Heck yeah, dude. Welcome, Nate. Welcome, welcome. Is this right? It's probably right. If I take this example that I haven't messed with, this should be 2024. Okay, clearly that's not right. What is this number then? What is it? What is this trying to do? Now I'm just curious. Didn't solve it yet. Now thinking, do I need a spoiler? Oh yeah, don't spoil it if you don't want to. Oh heck yeah, 290 followers on Twitch. Love it. Let's go. Oh, expand / sequences. Okay, cool. Can I do this? We have S equals. Let's go generate that binary string again. Make sure we just have the right one. This should be 2024. Let's save that to a variable like this. And then can we just echo 10 # the variable? Do I have to do this? that just got rid of the leading zeros. Oh, wait. Okay, well that's interesting, isn't it? Let me test this real quick, because now I'm curious. What is it? O base equals 2? Oh. What am I doing wrong? I can't believe this is the part I'm faltering on. This seems silly to me. Oh, according to this, I might actually have the wrong answer. Is my answer backwards? My answer might be backwards. 0, 0, 1? Yeah, that should be 1, 0, 0, shouldn't it? Okay. I just actually have my answer backwards. Okay. Yep, I just literally had that backwards. That's it. Okay. Okay, so this will work now. 2 pound sign and then the variable. Okay. Two pound sign and then the variable. That should be 4, correct. This should be 2024, awesome. And this should be the answer to part 1. Oh, I base, yeah, that makes sense. I for input, O for output, makes perfect sense. Cool, let's test this out. This might be one of the fastest puzzles. Yeah, this is awesome. Take this giant string that I got from my terminal. We're gonna paste it here. And y'all ready for this? Let's go. Let's go. That's the right answer. You are 1 gold star closer to finding the chief historian. Hey, look at that. This was very straightforward. Luckily, I'm not too afraid of logic gates. I'm gonna regret these words with part 2, aren't I? But yeah, we nailed it. Part 1 down. Very quick part 1. Masterclass, super well done. Yo, appreciate it, thank you. Yeah, when it's not math heavy, I excel. When it's like programming and logic gates and Boolean operators, hey, I was built for this stuff. Too fast, I'm still awake. Sorry, I'll slow down a bit. After inspecting the monitoring device more closely, you determine that the system you're simulating is trying to add 2 binary numbers. That's what I said. That's what I said. And, or, XOR, using output bits to generate a number. This is an adder. This is an adder machine. This is probably going to be some sort of full adder or half adder type thing. I've done these before. I'm familiar with them. It's been a while. I don't know if I could recreate the circuit from memory. I probably could. A and B XOR together. XOR with the carry. That's your sum. A and B logically ANDed together. The carry and the XOR sum logically ANDed together, and then a final OR, and that's your carry. But I could recreate this. I could absolutely recreate this. I have so much experience with this. Yeah, nailed it. Yep, nailed it. Oh, I'm so glad. Do you know what it's like to look at it? Okay, I haven't even finished reading part 2, so I should probably stop jumping ahead. But do you know what it's like to read a problem and be like, oh, this is in my wheelhouse? It's such a good feeling. Oh my God. I could eat these words. I could be completely wrong here. So we'll just, we'll see. We'll see. Let's see. Specifically, it is treating the bits on wire starting with X as one binary number, treating the bits on wire starting with Y as a second binary number, and then attempting to add those 2 numbers together. The output of this operation is produced as a binary number on the wire starting with Z. In all 3 cases, wire 00 is the least significant bit, then 1.2. Okay, cool. The initial value for the wires in your puzzle input represent just one instance of a pair of numbers that sum to the wrong value. Oh God, it's gonna be wrong. Oh. Okay, I'll have a hint when needed. Oh God, come on guys, you're making me scared for part 2. Oh yeah, the spice. I'm nervous, man. Oh man, don't hit me with it's already wrong. Okay, let's see. The initial values for the wires in your puzzle input represent just one instance of a pair of numbers that sum to the wrong value. Ultimately, Any two binary numbers provided as input should be handled correctly. That is, for any combination of bits on wires starting with X and wires starting with Y, the sum of the two numbers of those bits represented should be produced as a binary number on the wire starting with Z. Okay. Okay. Hype level dropping. Listen. For example, if you have an addition system with 4 X wires and 4 Y wires and 5 Z wires, right, for a carry bit, okay, you should be able to supply any 4-bit number on the X wires, any 4-bit number on the Y numbers, and eventually find the sum of those two numbers as a 5-bit number on the Z wires. One of the ways you could provide numbers to such a system would be to pass 11 on X wires, 1011 and 1101 in binary. Okay. If the system were working correctly, then after all gates are finished processing, you should find 24 on the Z wires as the 5-bit binary number process. Cool. I'm not going to go through and verify this, but yeah, this is we're just adding binary numbers. Cool. Unfortunately, your actual system needs to add numbers with many more bits and therefore has many more wires. Gotcha. Based on a forensic analysis of scuff marks and scratches on the device, you can tell that there are exactly 4 pairs of gates. Pairs of gates. Pairs of gates. I need to make sure I'm reading this very carefully. Whose output wires have been swapped. A gate can only be in at most one such pair. No gate's output was swapped multiple times. Oh, thank God. Okay. For example, the system below is supposed to find the bitwise AND of the 6-bit number on X0 through X05 and the 6-bit number on Y0 through Y05, and then write the result as a 6-bit number, Z0 through Z05. Okay, that's easy to logically end them. You just logically end every bit. Correct, yeah. However, in this example, 2 pairs of gates have had their output wires swapped, causing the system to produce wrong answers. The first pair of gates with swapped outputs is X0 and Y0 to Z5. Oh, I see. Okay, we can very easily visualize that these are going to the wrong one. Okay. The first pair of gates with swapped outputs is X0 and Y0 005. Second pair of gates is... I see. Okay, so a pair of gates means those 2 gates have been swapped. That's 1 pair. There are 4 instances of swapped gates. Okay, I'm following. Correcting these 2 swap results in the system that works as intended for any set of initial values on wires that start with X or Y. Okay. In this example, 2 pairs of gates have outputs that are involved in a swap. By sorting their outputs wires name and joining them with commas, the list of wires involved in swaps. Okay. Only the outputs are ever going to be swapped, and only these ever outputted to Z, so that's why. So the output is the thing, the unique key that we use to identify these swaps. Okay. Makes sense. 2 inputs, 1 output. Just look at the output. Of course, your actual system is much more complex than this, and the gates that need their output swapped could be anywhere, not just attached to a wire starting with a Z. If you were to determine that you need to swap output wires AA with EE, OO with Z9, BB with CC, and AOC with Z24, cute names, your answer would be AA, AOC, BB. Okay, so you just sort, yeah, okay. So there were 4 gates that were swapped, 4 pairs of gates involved in a swap, meaning there were 8 outputs that were involved with swap. So we have 8 in the output sorted alphabetically. Okay. Not gonna lie, I solved this one mostly by hand. I don't know how to write a general solution. Hey, that's interesting. We may end up doing that. We totally may end up doing that, and I'm not against that at this point. 24 days in, yeah, I'm not against that. So we'll see if we can do it. Your system of gates and wires has 4 pairs of gates which need their output wires swapped, 8 wires in total. Determine which 4 pairs of gates need their output swapped so that your system correctly performs addition. What do you get if you sort the name of the 8 wires involved in a swap and then join those names with commas? Okay. So we have an adder machine that is incorrect. Because what it's supposed to do, if I understand this correctly, our machine is supposed to add numbers together from X and Y and then create Z's. So I'm thinking we can go through and come up with very simple examples Very simple examples that we could feed through this machine where we try to add them like bit by bit or something. Let's see. The main reason I haven't finished this one yet is that I've been sticking to writing code for it instead of solving by hand. I know I'm making it more difficult for myself than it needs to be. There goes my hint. Oh my God, was your hint to do it by hand? Listen, man, oh, my brain's churning. I used software in the past to visualize circuitry. So like, it might even be advantageous. I probably won't do it, but like to take these input connections and try to output it in a way that I could put it into a visualizer. And then I know what a full adder system looks like. I would just look to see what wires were misplaced. Yeah. A bit more involved than just that, but yeah. Okay, gotcha. All right, I'm going to make sure I have this fully understood in my head. And then attempting to add those numbers together. So, yeah, okay. So this is supposed to be an adder machine. I got it. Okay. Let me start thinking about possible solutions. I'm gonna talk out loud. We could start renaming some of my inputs, some of my wires, because we have these wires that have completely meaningless names. But we could check, like if the wire's connected. Trying to think of how we would name them. I don't exactly know how we would name them. We know where the X and Y's are. And we could start going forward, like X0 should connect to... Actually, yeah, let's think about this, because if we have X0 and X01, then... Let me imagine this. If we have a full adder machine, at some point we have to logically AND those together to determine if there's a carry bit. We also determine if there's a carry bit by looking at the XOR sum of them and the carry from that through a logical AND, and then that finally goes through a logical OR. So we could start naming them and then see where the naming falls apart. Ooh, this is a tough one. This is definitely a tough one. Because we know what the values should be. Interesting. This is so interesting. Okay. I can think of a couple ways. Here's a couple ways. I could make it a text file, my own text file that has, you know, 2 X's and 2 Y's and then adds them together. So I could come up with what a full adder machine would look like with really well-named wires. And then we could, like, you know, swap a wire and check to see like where it fails or how a failure starts to propagate. We could try drawing connections. I don't know what that gets us, but yeah. Yeah, I mean, okay, I'll click the link. But yeah, I mean, if it's a full adder machine, it's going to be A and B logically ANDed together, A and B XORed together, that XOR sum going through another XOR with the carry, and that's your sum, and then the carry going through a logical AND with the XOR sum, and those 2 ANDs that I talked about being ORed together to your final carry out bit. Like, I know this circuit stupidly well. It's exactly what I'm describing. Yeah. Yeah, I just click it. Yeah, I'll do that. Thank you. Good point. Sorry. Yeah, this is useful for my actual stream to see this. This is what I'm describing, everyone. And if you've never seen this, I'm sorry, it's really hard to explain. But if you've done like Boolean logic and gates and stuff, this is exactly what's happening. We have our in, and our carry. So in this example, it'd be like an X here, a Y here. And so if it was like X0, Y0, there'd be no carry bit. It'd technically be like a half adder machine because that's the first one. But then for like Y1, X1, this would be Z0 probably. We can double check this, but yeah, you just XOR them together. That's your sum, which throws out the carry. Basically, XOR allows you to add binary numbers together, but it throws away the carry bit. So this does the easy part of addition, and this does the really, really hard part of addition, which is maintaining whether or not you threw out a carry bit. This is why in your CPU, when you're doing like math instructions, it keeps track, and there's like flags that get turned on if a carry happened. So you can actually like detect overflows and stuff like that. That's why it's funny. You see these old video games like on the regular Nintendo where it's like, yeah, it would just get to 256, then it would, you know, overflow back to 0, and they couldn't detect it. It's like, hold on. They could detect it. Absolutely, the carry flag got set, and you can check that. It's just very expensive, and you might not want to. And if you don't expect them to ever get that high, hey, you know, whatever. So, but yeah, okay, this is a good thing. I can revert back to understanding this, but yeah. And this is useful because we know there are 5 gates to add 1 bit. So in our example, let me think. Was our example input that they gave us right here, was this supposed to be a fully working adder machine? Because, I mean, that depends on a lot of these things. My assumption is that the example they gave us, if this was working correctly, it shouldn't give us 2024. It should give us this plus this. So what's this? 0, 1, 1, 0, 1. Yeah, let me just write these down. So, XC. I know you can't see this. 0, 0, 1, 1, 0, 1. Y equals 1, 1, 1, 1, 1. Okay, so I'll show you what I'm doing. I just saved these. So now if I do 10 base $A or $X, actually I can just add them together, right? No, because it treats them right. I have to do 10 base. So it gives me these, which is not what I or no, maybe that is what it expected. It gives me 2024 erroneously, and it wants to give me these. Yeah, I'm confusing myself a little bit. Are we just concatenating them? What's happening here? Let's see. I think you want 2 pound, not 10 pound. Almost certainly 2 pound. Yeah, I always get those backwards. Isn't that like, it's just, of course, that's how it goes. So I always get them backwards. Yeah, 44. Okay, and then so this is the number you should get if you add this together with this together. Yeah, even just adding 1 to this puts the 1 in the carry, so you're definitely going to get the carry, and then you're just left with these up here. That makes this is the easiest math to do, because you take this 1 right here, you add it into here, and then you just have a whole bunch of zeros, so these just get retained. Yeah, this is what it should be. Okay, so the answer should be 44. Yeah. No, for this one specifically, I want O base. Because I want the output base to be 2, just to print this to binary. So yeah, this makes sense. Yo, what's up, Zine? How you doing, man? We're good. We're chilling right now. I'll just do that. I'll be better about explaining what's going through my head. So here's what we have. And then the answer was this. And we can verify this by just writing it out like a math problem. So we could have like... There we go. So this is correct. This is what it would look like if you added those 2 things together. So, yep. For the first case, YT hangs. Oh, okay, gotcha. Yep, so this is correct. This is right. That's what the answer would look like if we were correct. We are getting 2024 for the example, so something is wrong. Cool, so go ahead and everyone just take this in, and something's wrong. So here's what I propose. Let's start randomly flipping outputs in groups of 4 until we get the right answer. I'm kidding. We're not doing that. We'd have to, God, it would explode so quickly how many we'd have to do. And on top of that, if we got the right answer, we don't even know the full adder machine's working. We just know that we got it for that specific case. Oh man, that's really funny. Random sort, you got it. Let me try this. I'll leave the stream them. Listen, I understand. How many ands do we have? I see it. Flip that one. See, Dark Space understands. Dark Space knows what I'm asking for. See, Dark Space is actually doing the thing I asked for. You gotta look it over and just tell me what's wrong. Come on. So we have 10 XOR gates, 9 AND gates, and 27 OR gates. That's interesting to me because for a binary adder machine, we don't need all of those. We just need 2 ANDs, 2 XORs for every 1 OR. Hold on. I just realized searching for OR will match XOR. So that'll throw off the results. But also, there's totally no rule that says that we can't just have extraneous answers in them. Like, we can just have gates in there that have no purpose. That's totally possible. Yeah, we have 9 ANDs, 10 XORs, and we have twice the amount of ORs, whereas with a full adder machine, we wouldn't need that many ORs. So, yeah. Rust plus multi-core. You got it. You understand. Oh, man. Let's see. You joke about it, but that's what I ran while I slept after I couldn't figure it out at midnight. Listen. Okay. That's wild. I mean, that's pretty awesome that that's what you did, dude. I can respect that. We need to figure out a way to visualize this. So I'm thinking of a couple ways to visualize this. We know our Z's are our output. We could start from our Z's and work our way backwards. So we could depth first search from a Z, go down the tree because each gate expands into 2, and we could figure out all of the... You didn't get closer to the answer. We could figure out where the roots are from everything, but we could also do a couple different things. We could calculate the roots. Roots are really easy to calculate because they have initial values set, so we actually already know all our roots. So let me think about this. Let's look at our example input. CP example to example renamed.txt. This way we can safely mess with the example here without worrying about it. So we have roots. Roots would be like x00 is a root. So one of the first things we do is we logically OR x00 and x03 into FST. I don't know why we would ever do that. Why would you ever take 2 of the digits from the number you're adding together and logically OR them together? So I'm guessing FST doesn't show up anywhere in a way that matters. So, oh, but this, I'm just doing the manual solution, aren't I? I'm totally just doing the manual solution. FRJ shows up immediately here. Did they show us how to fix our example? I think they gave us a different example and showed us how to fix it. Yeah, they gave us a different example. What's up, Robin? How you doing? These aren't in here, right? Yeah, no, these were just examples they use. So they actually didn't give... So in the Advent of Code thing, they didn't actually... Eric didn't show me how to fix the example text. He gave new, very simple example text to illustrate what a swap looks like, but not the 4 I would need to swap in the example, assuming the example can even be swapped to make it make sense. I'm going to just, okay, here's what I'm going to do. I'm going to start writing some code, and I'm going to see if I can get something visualizing that can help us out here. So we're going to take part 2, which is just part 1. We've already read in every possible thing, and we went through and grabbed the values of all the wires. That's fine. We can keep doing this. It's not a big deal because this happens super duper fast. Okay, so what we can do here, so we'll just close these out. We'll just, hide these echoes. They're not a big deal. So now if we run part 2 and we read in from our example, not the rename, we'll just read it from example input, we get this. What was wrong with this? What did I change that would have broke this? Yeah, wait, part 1 works. What did I change in part 2? Didn't I just get rid of echoes? I don't know. Let's just redo it. There we go. Hey, look at that. I thought I just got rid of echoes. Maybe I got rid of other stuff that mattered. I must have, without realizing it. Okay. Or no, wait, hold on. Sorry, I'm lying to you. Were these errors always being generated by part 1? Did part 1 have errors even though it gave us the correct answer? Cool. Part 1 was giving us errors and we didn't even, like, know? That's cool. Beautiful. Okay. Yeah, we can just do this. Okay. All right. Wow, we were getting errors there, but yet we were still getting the right answer. That doesn't inspire confidence. Or it inspires false confidence, however you want to look at it. Oh, I gotta stop doing that. I just keep copying over it. You know how annoying that is? Oh my god. But I am getting good at finding all the echo statements, so that's something. Don't copy. Don't copy. Don't copy. There we go. Part 2. Read in from example. Input. There we go. Pretty fast, too. Awesome. Awesome. So we can do this. I don't know. Loop. Let's investigate a single output. We're going to pick Z00. Just because, why not? Let's grab the equations for this output. Classic example of too much logging hiding the actual problems. True. True. How do we want to do this? Do we want a breadth first search or we want depth first? We probably want a depth first. So let's make a function called dive. And we'll just call it recursively. So what we'll do here is we will dive into Z00. So we'll do everything in a function here. Grab the equation for it. If there's no equation, then we're done because it just had a static value. If -z equation, then we return. There's nothing to do here. Otherwise, we need to dive into the left and right side. So we need left-hand side, right-hand side, read-r left-hand side hyphen right-hand side from equation, and then we need to dive left-hand side and dive right-hand side. We're going to the left-hand side first. Doesn't matter. Doesn't matter how far we bias. Once we get here, then we've reached the end, so we just figure out what to yeah. Heads up, I just double-checked the first example. It is not an adder and does not follow the only for swap pair rule. You can't use that to test. Okay, thank you. Here's the thing. It's so funny. I'm glad you said that and confirmed it. I was going to say that I don't know why we're going to think it's an adder, and I think that's a problem. Like, I was going to use it to test this logic, but I do think that making the assumption that it's an adder is not right. These puzzles have been very explicit, and it didn't tell me it was one, and I think that might be a mistake. So I think we're going to have to create our own adder in text and then see what it looks like. I think we will have to do that. Yeah, and thanks for checking. I haven't remembered yet. Yeah, I appreciate that. I think I would have bumped my head against it pretty soon, but I was going to make the assertion that we should just build our own. That way we know it works. And if we build our own adder in text, we can test it. We give it our own inputs and outputs and get what we expect. So, you know, that's pretty cool. I don't think I've ever built a full adder in text, so that's something. We should keep track of what we've seen. Don't shift. All. Okay. Every time we call dive, we're going to give it another argument, which lets us know how deep we were into it. So that way, when we're done, we can say echo root reached all yeah, that should work. Let's do our simple example. Let's do our example input. Okay, so in order to get to the root of x03, x03 will go to VDT, go to BFW, and go to Z00. X00 will go to VDT, BFD, and Z00. Okay, so what we could do now is we can store the operation, and we can actually get something useful out of this. So what we store in all is we will grab the up. I think we can do this. I think this will make sense. I might have it backwards, but I think we're okay here. Let's do this instead. Let's printf. No, let's do this. Get ready for some gnarly syntax. Instead of joining them by spaces, we're going to join them with arrows. Can we do this? Or do we? No, we just use the first letter of the IFS, don't we? That's okay. Yeah, the spaces is okay. This is okay. So that is correct. So now if we do the example input. Okay, so in order to get to this root, y equals 2, we need to logically OR it with FGS. That gets logically XORed with MJB. That gets logically XORed with Z00. Hold on, wait, this isn't... It's actually Y02 and something else gets logically XORed with FGS. So Y04 it looks like does. Okay, that's interesting. This is interesting. Okay, I think we're onto something. I think we're onto something really cool. Because if we can get this output, we can start looking for things that don't make sense. So are y'all ready? We're going to make a full adder. And the full adder, we're going to make a 2-bit full adder. I'm sure you know what? We should probably just make a half adder. No, let's make a full adder. Let's do that. Let's see if I'm smart enough to do this. Y0 is 0. X0 is 1. Or I'll do a Y1 is 0. This is 1. X0 is 0. X1 is 0. Okay, so we're going to add 1 and 1 together, so we should get 2 as the answer. Yeah. That means we need a Z0, Z1, and Z2. Okay. Let me look at the circuit here. We have to translate this into an actual thing that makes sense. So in order to do this, we have to take the X0 and the Y0, and we have to first XOR them together into something. So X0, XOR Y0 into XOR 1, 0. The reason I'm calling it this is because I'm using this diagram. So this is XOR 1, and this is XOR 2. This is AND 1, and this is AND 2. So XOR 1 is what it is on the diagram, and then the 0 is because we're doing the 0th element. That's kind of how I'm embedding this into it. So now the next thing we can do is we also have to AND them together, which will be x and 1, 0. And then we have to, this is wild. That's exactly how I use the diagram to inform my variable names. That's awesome. That's awesome. We also have an in carry, but that's okay, because that's just the carry from the previous one, which in this case won't be anything. Do we have to set it to anything? Let's just create, I don't know if this is necessary, but we're going to make a carry bit at 0, and we're just going to set it to 0. So we're clearing the carry effectively here. So the next thing we need to do is we need to, yeah, what's up, Matt? How you doing, man? We need to XOR the in carry with the output of the first XOR. So we need to XOR the in carry with the output of the first XOR, which is XOR 1, 0. And that will give us XOR 2, 0. This is so ridiculously verbose. The nice thing is the way I'm parsing the data, technically we can do it like this. It's okay because it's a variable number of spaces, so we don't have to worry about that. So that's kind of nice. So now we have this going into XOR 2. Yeah, XOR 2 is created from those two things. Cool. And then the let's see. We need an XOR 2. Hold on. XOR 1 is these two things. XOR 2 is these two things. And that will be the sum of the first one. So we could also technically call it the sum. Let's do that. I think that's easier to understand. Sum of 0. Then, which will actually just be a z, I think, but we'll get to that when we get to it. Then we need to logically AND the carry and the output of that first XOR. So we need to logically AND the carry and the output of that first XOR, which is XOR 1, 0. And that is how we create V2, which they call it in this diagram. We'll call it V2 because that's what they call it. Okay, so this and 1. This is brutal. This is just brutally confusing. Let me rethink these. So x0 and y0 get XOR'd together, and that creates v1. X0 and y0 also get ANDed together, and that creates v3. Again, this is the diagram I'm using. I wish I could put both on stream at the same time. It's not easy. Cool. And then we XOR the carry and the v1 together, and that gives us the sum. Cool. And then we AND the carry and the v1, and that gives us v2. And then we OR v1 or v2, and this gives us the carry out 0. Okay. And then we can just say that, cool, so now we have the sum out for 1 and the carry out for 0. This is the least significant bit, so this sum out for 0 is actually z00. the next bit. This one is the carry out 0, so this one goes into the next adder machine. Let's call this 0v1. Okay. Yeah, this V1 is kind of annoying, so we'll do 0v1, 0v1, 0v2, 0v3. Okay. And then this is going to be almost identical, except for x1. It's going to be all these things. Okay, and this goes to C2. But this is the end, so it actually goes to Z. No, this still goes to Z2, or C2, because this is the final carry, which goes to Z02 because it's the end of it. Okay, so the beginning ones have a static carry. This has, if we did this right, this should be a full adder machine where we give it the number 1, and we give it the number 1. Number 1 here. Number 1 here. In fact, you know what? I've written my code in a really nice way, so I can just say, like, I can comment it. Initial carry, input y and x bits. Okay. Top, left, XOR, top, right, XOR, middle and bottom, left, and bottom, right, or carry out, sum. Cool. So now, if we were to run part 1 against our full adder, we'll get some errors. Okay, so I know what's going on. Okay, it's the way I read in the values. I just need to put a throwaway variable here. There we go, and it will throw out all those comments that I added. Okay, so the final is 0. That is incorrect. But we know our code was working, so I think we got the adder design wrong. What if we did part 2? Let me do the same thing here. Throw these out. Throw these out. Part 2. Read in from full adder. In order to create the carryout for 0, we XOR with Z00. These aren't really useful yet. We have 3 Z's here, and this thing is detecting them properly. We also have an issue. Oh, I can't do this. I can't do that at all. I can't just add spaces when I want to. I wasn't prepared for that. Cool, so that's incorrect. Let's var dump values. Okay. So we have successfully read every single value as being 0 across the board. So we're not doing something right. In order to calculate Z02, we need 1v1 and 1v2. X1 and X, yeah. In order to get C1. Okay. Trying to solve Z01, couldn't do it. Can you have variable names starting with O, or am I reading that wrong? I don't know if the puzzle allows you to, but my code shouldn't have an issue with it. I'm storing them as keys in a hash map, so yeah, this is not going to be an issue. It's just a giant string. Solve 1v1 XOR these two together. They're both 0, so... Hey, wait a minute. X1 and Y1 are the same values. X1 is 0, Y1 is 0. When we XOR them, they're the same. Oh, so we should get 0. That's correct. Well, all our logical operations are right, but something isn't correct here. Yeah, so this should make its way to the carry. Hold on, I'm gonna figure this out. Alright. First thing we do, top left XOR. We XOR these together and we store it in 0v1. That makes sense. We're looking at the 0-1 with the v1 spot. That makes sense. We XOR the carry with the 0v1, the thing we just did, and that gives us our sum. Yes, that's correct. Then we AND the carry and the 0v1. That makes sense. This is 1/2 in determining if we still have a carry, so that goes to 0v2. Then we logically AND our two inputs together to 0v3. This is the other half of figuring out what we have carry, and then we have to logically OR them together. We don't logically OR them together. Okay, we are logically ORing these two together into the carry. This is wrong. They should be like that, which means that these are wrong. And they should also be like that. Okay. Last bit carry needs zone Z out. It knows the 0v3. Yeah, that's what's happening. Yep. What's up, Travis? How you doing? Final is 2. Hey, did we make a working full adder? I mean, a working full adder for 2 bits? I think we did. I think we did. This is pretty cool. So let's set all the bits to 0. We have the initial carry set to 0. We have the x1, x0, y0, y1 equal to 0. And we get, let's stop printing so much here because it's making it hard to find the final answer. Let's just exit 0 here. So all the way to the bottom. Final is 0. That's correct. If we add 0 to 0, 0 and 0 together, we get 0. What if we add 1 to a whole bunch of zeros? We should get 1. Hey, the answer is 1. Awesome. Hello. Hello to you as well. What if we add 1 and 1 together? Hey, Dave, didn't we already do that? Yeah, probably. We got 2. Awesome. What if we add 1 and 2 together? We get 3. What if we add 1 and 2 together? We get 3. Nice. What if we add 2 and 2 together? We get, our number is too big. I put the number 2 in there. Okay. We get 4. Look at that. Look at that. We get 4. What if we add 2 and 3 together? We get 5. What if we add 3 and 3 together? We get 6. And then what if we turn on the initial carry, which we'll never do? We get 7. We have written a full adder machine. We have written a full adder machine in Bash. How silly. Let's extend this. Let's make this... we're gonna expand the kind of data I expect here. If dash n LHS or continue. What I just put right there allows us to add new line breaks in our code here, so we can better understand this. I'm going to add a couple more bits because this one relies on an initially set carry, which is there. And yeah, so and this one writes its carry to the output. So what I can do is I can take this, put it here, and then we can just go through and change all these 1s to 2s. Make sure we get them all right. Dave, isn't it confusing that sometimes they're at the beginning and sometimes they're at the end? Yes, that is confusing. You are correct. That is very confusing that I chose to do it that way. So now we should have a 3-bit adder machine. And with 3 bits, we can do y2 equals, put like a 0 here, and x1 equals, I don't know, we'll leave it as 1 or something. So now we should have a full adder that does 3-bit work. Or it gets stuck in an infinite loop. So remember when they told us there'd be no cycles? I didn't make that promise. So now we just have to look for where I put my loop, which should reveal itself to me imminently. Oh, yo, what's up, Ash? How you doing? Hey, welcome. Welcome to the stream. Our inputs are wrong. Okay, there we go. Cool. So our final is 10. I didn't actually check to see what numbers we had. We have this, which is 7, and we have this, which is 3. 3 plus 7 is 10. Hey, our full adder is working. Heck yeah. How we doing tonight? Tonight, we're doing really good. We're doing really good because this puzzle is in my wheelhouse. We already knocked out part 1 so fast, and now we're working on part 2. I feel bad about this puzzle, though, because for anyone in my audience who isn't familiar with Boolean logic gates, this is very difficult to understand. I just happen to be comfortable with these, so I'm okay with this puzzle. But for some people who haven't seen this kind of diagram can be very confusing. We reconstructed this diagram. We reconstructed 3 of these in pure text, and now we're running code to run through simulations of them, which sounds ridiculous, and it kind of is. But it's working. I'm adding binary numbers together. I could convert this to redstone and do it in Minecraft if I wanted to. So we are making some really, really solid progress. My goal is to represent this in a way that we can make sure that all of the connections we need to be there are there, and no other connections that we don't care about. I don't know how we're going to do that quite yet, but we will get there. So let's get rid of this var dump. Let's get rid of this. Let's put like a echo equal, something like that. And then we'll get rid of, okay. Did we? Oh, we only dove. Yeah, we only dove into Z0. Okay. So if we do this against the real input, well, we already know it's wrong. Like, this is super interesting. Yeah, Z0 is created by XORing Y0 and X0. So let's try this. I'll take it as an argument. We can give it like cat example input into part 2 Z01. And we can see like, okay, that's how we make Z01. This is so interesting. But we don't care about the example. We care about our full adder. So starting from Z01, these are all of the things that were required to give us a value at Z01. I don't know if this is useful, but we're getting there. You know what I mean? So if I were to look at the real input, I can see that none of this mattered. I'm thinking, in order to do this, yeah, we needed this chain. We need an XOR and or XOR. We need and we could make a chain of operations we need. Now, already with my real input, I'm getting the feeling that Z0... No, wait, hold on. Z00 is wrong. Z01 is wrong. They can't all be wrong. Oh my god, maybe they could. And Z05 is wrong? Did we just... 1, 2, and 5 already. I just judging by how little output they generated, I have a feeling they're wrong. But it's just a feeling. It's just a feeling. What are the... I think it's 45, right? So let's do this, and then we can do just run it against all of them and look for one that's significantly smaller than the rest of them. It's definitely less than ideal, but like, yeah, this isn't super useful. I have to say, this is a really cool puzzle. This is a really unique puzzle. I haven't done many puzzles, so I shouldn't maybe comment on how unique they are, but I really like this one. Yeah, I'm trying to... so, like... using my full adder... yeah, they're always going to do this. They're always going to grow with each one. Yeah, they're always going to grow. We could stop at a certain depth because we know we're just going to traverse into the carries. Like, we could stop once we hit a carry. Without hitting a carry, we know that there needs to be an XOR and or, an XOR and or, an and or, an and or. This is, I mean, oh my god, this is so cool to see. This is actually a really cool way of seeing it, because in order to generate the least significant bit, all you do is you XOR them. Like, that's all you do. You just XOR two numbers together, because XORing numbers adds them. It loses the carry, but it adds them. Like, that's so, I don't know, that's really cool. That's really cool to me. So in order for it to be valid, we need 2 XORs in the chain. I'm just trying, just trying to understand. Like, this is wrong. No, it's not wrong. No, it's not wrong. No, it's not wrong. I'm wrong. I'm wrong. Technically speaking, this would be right. You just XOR them together and you add them. Like this, that would actually be right. That would actually be correct. And then in order to do this, we have WMQ and we have WRS. I could copy the real input to a new file, set all of the input bits to 0, except for like the first one, and just count up. Just start counting up. And then eventually I will hit an issue where I get the wrong answer. Start counting up in the X's, start counting up in the Y's until I get the wrong thing. And then that'll tell me where the issue is. But I would like to draw connections. I think that's what I need. I think I need more connections than what I have here. But I just need to figure out a way to visualize this in a way where I can easily spot issues. These last puzzles have really made me just have to sit and think, like real heavy think. Which is good. I love the feeling. It's exercising your brain, dude. It's good for you. This is where I stare at the input and try to think of different ways to represent this. It's a lot of numbers and letters. Isn't it ridiculous? But like, it actually can mean something meaningful. Like, that's what's crazy about it. Thank you, Ash. Beautiful support. Okay, so Z00 is connected to this input, which is connected to this. It's connected to this. And it's connected to the carry out. Oh, this makes sense. I said carry out. Mine has the initial carry in. This real input does not have the initial carry in. This real input's been like optimized or normalized. It's gotten rid of that. Mine was very verbose. This does not have it because it doesn't need it. So I would actually venture to say that Z00, this bit is correct. Now, when we look at this one, there's a couple things going on. In order to set Z01, 2 different pins go into it, and those pins were set from this. This is a very confusing way of looking at it, but like, if you condense Z01 into one thing, and you condense these into 2 things, it's like 2 become 1, and that 1 becomes 1. So 4 becomes 2 becomes 1. That's kind of the way to understand it. It's like a tree. It's a tree structure. It's actually a neat visual. Yeah, it's cool. It's neat. It's an interesting way to see it. And I think by doing this, I can calculate what a valid visual should look like, assuming there's not extra stuff thrown in here. Like, assuming there's no logical... My brain, I'm a sysadmin, so I've been burned by a lot of things. My brain thinks of all the possible ways I could make this more confusing, but I have to remember Eric's puzzles aren't mean. They're not mean. Like, they usually just, like, every gate in here probably is the only gate that's required. No one answer that question. If you know if there's extra gates or things in there to trip you up, don't tell me. But I'm assuming, like, it almost seems like I can assume there's not. I'm just so reticent to assume things. I wonder if it even makes sense to flip this output backwards so they all start at Z02 and then I can see how they fan out into the inputs that make them. I'm going to do that real quick. Yeah, that's an easy fix. I just push these to the end. So we're just going to reverse those orders. And we're going to break it by doing that. Cool. What did I do wrong? Oh. Yep, I can't do that. I push it to the beginning, and then we're going to dive into that. We get into an infinite loop. I'm making a mistake of representation and important data in the same thing at once. So, to do this, we'll just do Shift, All, and we'll put this wire at the back of the wire. Yeah, I think that's right. That looks right. We'll be seeing the ASCII art version of the diagram I posted in no time. Exactly. Like, this is one of those problems that visually the answer would make itself known very clear. So, I mean, like I said, I've said this multiple times. A lot of these problems are representation problems. If I could find a way to represent this where the issue jumps out immediately, then we're good to go. I like this one. In order to calculate Z02, we need KTR and SSD. In order to calculate SSD, we need these two. In order to calculate KTR, we need these two. In order to calculate this one, we need these two. Like, this makes sense. This makes sense. I suppose you could try to check given the different inputs. We couldn't really tell you for sure anyways. Yeah, that's true. That's true. We have different inputs. I could check. I thought about doing that too, if I should put like dead end checks or something, or inputs that aren't being used, or outputs that have no connections, you know, like a validator. I could do something like that. In order for this to be valid, something's jumping out at me. Let's use my full adder. In order for Z00 to be valid, we need to connect it to the two inputs. So Z0 should be connected to X0 and Y0. In order for Z01 to be valid, it needs to be connected to those regular inputs, and it also needs to be connected to 1. So everything we have here, it should, like if I give it like Z45, it should be connected to 45 and everything below it. Now that connection gets very deep, but that's what it, at the end of the day, it should resolve all the way down there and nowhere else. I think that's a way to think about it. I mean, my code is very simple. We can just follow these basic trends, but like we directly connect to X2. Not directly, we go through 1, but like at the end of our diving, we should have X2, we should have X1, and we should have X0, and it looks like just some carry out bit that we set. Okay. Now, let me try and do the real input. I did part 1. Okay. Okay. Yeah, this connects to 2, 1, and 0. It also connects to 1 here. Is that okay? I think it's okay. This connects to 3, but it also connects to 2. So 2 up here, a 1. Look at this. Well, Again, we don't know where it's broken. So it's possible that it could be broken real early. Like 0, 2 is connected to 2 here, 1 here, and then this up here. And I think this lines up with my input, my full adder machine. Yeah, we just have this extraneous V. That's why we get pushed out 1 extra layer. Yeah, our full adder goes here, 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 here. Oh boy, okay. So let me just see something real quick. how about, just for funsies, let's echo the wire. This should just be the root. Okay. Yeah, so we gave it Z02, so we have 2s, 1s, and 0s. If we give it 1, we should have 1s and 0s. If we give it 0, we should have just 0s. So if we did this against the real input, we only have 0s. We have 1s and 0s. We have 2s, 1s, and 0s. 3 1s and 0s. 4 3s, 2s, and 1s. Okay. 5. Look at that. Look at this. We're not... This is invalid. 5 is invalid. 5 is hooked directly into the output. So around the 5th bit, we have a problem. This is really cool to see. Now, I am under the idea that once we see one that's invalid, we probably have to fix it before we can move on and see anything meaningful from the rest of it. That's my impression. I could be wrong, but I would be inclined to fix 5 before we tried to move on. Because just because 5 had an issue doesn't mean the issues are going to be in other numbers. They could all be in 5. 5 has... Every branch has 5 logical gates. And we only need 4 logical gates with problems, so like... You know what I'm saying? So let me write a validator. Sort unique. Yeah. Gaps could also be an issue here. Sometimes I do this when I'm writing code or writing on the thing, so I can just scroll back to the beginning of the line and easily swap this one out. Yeah. It's one of those things where I'm like, do I really want to do it all by hand? It's like, dude, there's only 45 possible things. Like, it's not the end of the world to do this. But yeah, I'm tempted to fix 5 first. It's a nice alliteration. Also, we don't even know if the X's are disconnected here. Hey! Oh, 356. Yeah, well, that's never gonna match. Yeah, I'm inclined to fix 5. What is going on here? Why is this not control seeing? Oh. I switched keyboard layout somehow. Okay. Yeah, I'm inclined to do some switching. Real input, fixed.text. So, we know that part 5 is the problem, or 5 is the problem. What did I print there? Oh, I need Z. I need Z. I'm sorry about that. So here's an interesting question. We have to figure out what wires are swapped. So let's do this. X05 is here. We and or together, and this is the wire, right? Yeah, that connects it to Z05. We don't want to connect it to Z05. We want to swap the output wire with something else. And then something else needs to go into Z05. Okay. That's a good idea, Ash. I'll just go ahead and do that. You're like dark space over here. Yeah, yeah, dude, I see the problem right there. Just fix it. It's like when Bad Cop gives me solutions where I was like, yeah, my answer's off by 5. She's like, subtract 5, dummy. And it's like, dude, you know what? Based, actually. That's incredible. That's like a super sick way of dealing with it. Hey, look at this. We AND them together and we XOR them together. We AND them together. We XOR together, they go to VTN. But when we AND them together, they go to the wrong spot. So instead of going to Z05, we need to figure out what should be going to Z05. We could probably look at Z04. What goes Z04? Oh, great. A bunch of nonsense. How are we gonna solve this? I feel like sorting it would be useful. Like, put all the ones with a Y and an X at the top of this list, and then sort them, and then whatever they come next, they should come next. Doesn't make much sense. The only inputs that matter are X's and Y's. Okay, I'm thinking about this. The only inputs that matters are X's and Y's. So we can start with X0 and Y0 at the beginning, and then we can start moving everything down that has to be there. So like WRS would be next. Anything with WRS would come next. Let's write a tool to sort this. Yeah, they use X XOR Y and Y XOR X interchangeably, resorting. Because they're commutative. That's cool. Yeah, I'm not too worried about that. I think we just need to pick up one that has anything in it. If it's not a usual adder, how are you supposed to figure out what's wrong? Are there extra components? No, it's a usual adder as far as I can tell. I don't know if there's extra components or not. I doubt it. But there's nothing that explicitly said it was or was not. That goes into the carry bit. Okay. Yeah, of course you AND them together. Yeah. We add them together. We AND them together. That's our carry. So this makes perfect sense that we have a carry here. We're ANDing it with WMG. So WMG should be the sum of them. Yeah. The sum and the AND tells us if there's a carry or not. Yeah, that makes sense. It's so weird. I can picture this. It makes sense to me. I think I'm gonna write something. CP part 2 to sorter. I think we can start cleaning up this output a little bit. So we have all the equations and the minimum and maximum and everything. We have all of the equations. So we have min z and max z. For I equals 0, I less than equal max z. I guess this should be, let's just go steal this. We know this works. Okay, we've read everything in. Now we're going to loop over them Even though we call it Z, it doesn't matter. We have Z, X, and Y. Okay, these are our three things that we have to worry about. We can do the X first and then the Y. No, they're together. They're together. All right, so now that we have this, find everything relevant to these. If we find the ones that are relevant to Z0, yeah, and then we filter them out. Okay. We don't care about the value, we just care about the equations. And the X and Y won't have equations. It's just the Z that has them. I'm thinking. We need our dive function. This is wild what's happening here. I don't know what I'm sure of. I'm not even there. I'm just dumping out what's in my brain right now. Let's just make dive do this. This is my sorter function, so I can just move this up here. Let's run sorter on the full adder, and it should output a new file which is easier to read. Easier asterisks. Yeah, so in order to make Z0, we need to make OV1 and C0. In order to make OV1, we need to make Y0 on this one. In order to make Z01, this is the next Z in the chain, we have to do all this stuff. We need to make C1 and 1v1, so we have to find out what C1 is. It's these two. This one was made up of this one. So we basically are just walking the chain up and figuring out all that's required to make Z's. So if we do this correctly, in our dive function, when we get to a blank... oh, hey, hold on. Oh, yeah, look at this. How do I do this? I'm just going to put comments in here. And then I'm going to make my function just ignore comments. I think that's the way to do it. There we go. So now sorter, read in from the full adder. This is the one that we worked on. Hey, look at this. We're making progress. I believe that if I have done this right, we should be able to write this to a file, read it back in, and it should work. So sorter should just sort the output in a way that makes sense. And the way we can do that is we can just do this and then echo here. So if this works, this will just output another file that is valid. This should be a valid file. So let me show you what I'm thinking. Cat full adder, pipe it to part 2, and it works. It gives us the answer 10. Cat full adder, pipe it to sorter, pipe that to part 2, and it broke. But wasn't that a ton of fun we just had right there? How did that work? I must have done something wrong with my output here. But you guys see the vision? You see what's happening here? Oh, part 2 has to ignore comments. Where did I ignore comments? Did I put it in part 1? No. Did I not write that code? I wrote that code, right? Am I crazy? I don't know. That works. That works. Okay, this is really big brain what's happening here. We can sort the input into something that's more readable and digestible. So in order to make Z0, we just need this. Now they will grow exponentially. In order to make this, we need 2. In order to make this, we need, what is this, 6? And then this is going to be 10. What is it? 2 to the 0 plus 2. 2 to the 1 plus 2. 4 plus 2. And this one's 8 plus 2. And this one's going to be not right. I don't know. Whatever. I don't care. You put it in the sorter, right? I got the sorter right here. And then we run that sorter output through part 2. And sorter generates a valid input file. Oh, our version of valid, which is slightly different. So now, let's just get an idea. Cat the real input into the sorter. Let's pipe it to less. So here is what the real input looks like. Wow, this is wild to see. We can see 5 is clearly broken. 5 is a clear and obvious outlier. This is super cool to see. Oh, I love this. This is so sick. You're outputting duplicates, but as long as part 2 handles that fine. Oh, am I? That's funny. Do you see any obvious duplicates? Am I just like missing them or something? Oh, you're right. Yeah, oh, you know why? Because I'm not taking them out of the list of equations. Yeah, my thing does handle duplicates. I had this logic in my head and I just didn't write it. Once we output the equation, we should delete the equation. Yeah, so once we dive in and we grab the equation and we had a right hand and left hand value, we should get rid of it. So where's my dive function? Here's my dive function. Once we read in from that equation and we echo it, we should delete it from the equation. So unset equations equation. I think this will vastly simplify things. Let me double check and make sure. No, we still have duplicates. Why do we still have duplicates? Oh, pfft. Help if I use the right key, huh? There we go. Okay. Oh, wow. Okay. Oh, we're getting there. Look at this. This is what a good full adder looks like. How amazing is this, right? We've all seen a full adder. 5 gates in a full adder. We get 5 gates in a full adder. 3 just to store the final carryout, and the initial gate, we have this initial carryout set to 0. We technically didn't need that, but okay. So now if we take the real input and pipe it to our sorter, oh my god. This is a beautiful way of looking at it, isn't it? What's going on with 11? Why are there so many here? What's going on with 6? Why are there so many here? What's going on with 5? Why is there not a lot here? Wow. Oh my god, what's going on with 1? We have our problems. 1, 5, 6, and 11. Our problems lie in 1, 5, 6, and 11. Man, I did that step by hand first time around. That's brutal. That's wild. Oh man. It's my only experience here that's helping me is doing networking stuff, computer networking, having to, do like those kind of graphing problems that I'm really bad at. I always found visualizing them helps. And it doesn't matter what the visualization looks like, just as long as you can clump them in a way where you start to see patterns emerge. That's the only thing I found helpful. So we have 5, 6, 11, and 12. All the problems are in 5, 6, 11, and 12. Yeah. What we could do here, we could keep track of how many were in dive. This is silly. We could just add them all up at the end. I don't even want to do it. I need to write more sorters in Bash. Yeah. Yeah, so we have 1. So 3 is... Did we determine that 3 is not right for this? Should be 5, unless there's some sort of trick or normalization for the first bit that doesn't need as much stuff. Because we definitely have an issue with 5. We definitely have an issue with 6. We definitely have an issue with 11. And 12 doesn't have enough. So it's possible that number 1 could be done in 3 steps. Like, in order to make Z01, all we actually need to do is XOR WRS and WMQ. So we just need to... Yeah, because then the carryout is here, which grabs its value from... I think this is right. I think we're okay. So I think our problems are in 5, 6, 11, and 12. Okay. How do we go and fix those now? Five clearly doesn't have enough. And yeah, that looks like it just starts with a half adder instead of a full adder. Yes, I agree. That's what I'm thinking. Because I made sure to be overly cautious about mine and even bring in like an empty carry bit that we just manually set to 0. So this data looks like it's been like normalized. It's been optimized. They've just taken out the things they don't need. So here's something interesting. In order for each one to work, they need one to point to it and the rest to grab from the ones above it. So we need an AND, XOR, oh, we need all sorts of stuff. We need an AND of one before it, an XOR of the current one. AND of one before it, XOR of the current one. AND of one before it, XOR of the current one. AND of ourselves. That's wrong. And that goes to this one. So this one should be an XOR that gets written to Z05. So this Z05 is wrong. I'll open up another terminal to make notes. So Z05 is wrong. X and Y and Z03. Don't. I'll get to that. Don't point me. Don't point me to things that could be right or wrong. I'll just look around and see what I see. Yeah, let's see. Yeah, so this one writes to Z04. This one writes to Z05. But it shouldn't be. We should never be writing an AND to an output, unless we're no. Actually, the final output would be an OR that gets written to it. We should always be writing an XOR. An XOR is the sum. This is not an XOR. So we need an XOR of X05 and Y05. This needs to be written to Z05. And instead it's being written to VTN. So I think VTN and Z05 are wrong. And if that's the case, then when we logically AND them together, it would be written to VTN. And when you AND them together, it would go to WPN, which would get ORed together to get XORed in the final thing. Okay, so VTN gets ANDed together and becomes HVM. And HVM gets ORed together into JKM. Oh, this is difficult. But I know those are wrong. So here's what we'll do. CP real input to fixed.text vim fixed. Let's swap them. So this one should X05 and Y05 XOR should not be going to VTN. They should be going to Z05. And then let's find Z05, the other one, and that should become VTN. So this is 1 out of the 4 fixed. Let's go ahead and look at the new sorted output, because this should be a little bit easier to read. That is wrong. Oh, we're catting the real input. Always make sure you're catting the right file. Okay. This looks better, but there's still problems here. So let's figure out what the problems are. Y06 and X06, when they get XORed together, that should not be going to BMT. When you XOR the inputs together, they should be going directly to the output. This should be going, so BMT should be going to Z06. What about carry in? I have no idea. BMT Z06. We'll get to that. Not thinking about that right now. I think I need to swap those. And I could be wrong. I could just suddenly start swapping all these and then, you know, we don't get the right answer. BMT at the end of a line is right here. Let's make that Z06. Z06 at the end of a line. Let's make that BMT. Okay, that's clearly wrong. Because we shouldn't be in a situation where BMT XORing is being written back to BMT. We would not have a cycle. Wish you luck. It's upsetting with snore. Doesn't make itself. Yeah, have a good night, man. Take care. And I understand if this is not exciting. I'm okay with that. You won't offend me. So that's not correct. Maybe my methodology is wrong here. No, you're right about the carry. I understand what you're saying now. You don't XOR directly to the output. That's what you do for the first one because it's a half adder. You XOR to something that eventually gets XORed with the carry that gets written to the thing. You're right. Yeah, so this one is wrong because we wrote directly to the output. Well, I think I did that. Let's start over. Maybe that first one was right? I don't know. Yeah, X05, XOR, Y05 gets written to VTN. VTN gets XORed with something. VTN gets XORed with PVB, and that gets written to TST. Yeah. That's not right. It shouldn't go to TST. This should go to Z05. And that means these two together go to TST. So where does TST get used? Here. We add them together, we logically OR them, and this becomes the carry JKM, which gets used down here. Okay, we're making progress. This is a ridiculous way of doing it, but I don't know how to programmatically solve this. We write it to VTN. VTN XOR PVB gets sent to TST. TST should be Z05. Z05 TST. Hey, that looks a lot better, doesn't it? This looks a lot better to me. Okay, so 11's having problems. What are the problems here? A logical OR is being written to an output. That is not what should be happening. An XOR should be written to an output directly. So the XOR of the sum and the carry. The carry gets written to CDS is the carry. CDS is here. Is there more CDSs? That's it. Okay. So this is the carry, and it gets logically ANDed. The carry in gets logically ANDed and XOR'd, I thought. I'm looking at the diagram. It gets both of these. Oh yeah, it does get XOR'd. Yeah, okay. To the sum, and then it gets ANDed. Oh, that should be down here. What is VDR? Okay, so VDR is the sum of them, which then gets XOR'd with CDS. So CDS is the carry. How do we produce CDS? We do a VHV and a BJJ. VHV and a BJJ. And they're both created by ANDing with each other. Getting a little confused here, but we're definitely making something happen here. Wow, there's all sorts of problems here. It might make sense to jump into a different problem. Okay, all these look good, and by all look good, I mean have 5 and then 3 at the end. So let's go ahead and let's jump down a little bit here. Maybe we'll look at this one that has issues. So in order to create Z12, we XOR these two things together, FQR and SPS. In order to create them, two things get XOR'd together. So that's incorrect. The inputs get XOR'd together, and then they get XOR'd with the carry. That's correct. But the carry is created by XORing two data things together, which is not right. The carry that goes in that final XOR should be created by just the actual carry in from the last problem. Yeah, this is so confusing. We XOR them together, then we XOR that for the result. That looks fine. This is incorrect. So SPS is definitely an issue. But what is it swapped with? I don't know. But SPS is absolutely an issue. Where is SPS? SPS. Many things OR'd together. Hey, look at this. Why are we writing an OR directly to Z11? That should never happen. They should always be XORs directly to the final thing. So we know Z11 is also an issue. They could be the same problem, but we know Z11 is an issue. We don't want to OR them together. We want to XOR them together. It could be this, HKC and TDD. Oh yeah, it absolutely could be. Yeah, When they're ORed and XORed, yeah. I think these are a problem. SPS and Z11. I could also write a program that just like swaps the input for me, which might be kind of nice, but yeah. Z11. Well, this looks a lot better. They're all in groups of 5, but we know, because our puzzle input told us, that there are 4 other things that are wrong. So let's grep for Z. Let's also grep for an arrow. An arrow to Z. That's what we'll grep for. Okay. So all of these are produced by an XOR, which is correct, except for this final one, which is an OR, which is correct. Nope, look at this. That's an AND. Z23 is wrong. Yeah, some reason AND's coming together to give us that when it should be an XOR. So there's an XOR being somewhere used that shouldn't be happening. So what is KMG and PGJ? KMG? KMG is produced by an OR. And if that's produced by an OR, then that's a carry. Obviously, it could still be wrong, but that would be a carry bit. And we logically AND 2 inputs together to get PFS. And then we OR them together to give us a carry bit. Okay, that's fine. That's perfect. That's exactly how you would do that. You'd OR with the output of another AND. That looks good. Yeah, these are wrong. Because these 2 being XOR together should just write straight to Z23. And this one should write to, but this one can't write to PJG because it's already part of PJG. So the issue is there's couple things. There's going to be 2 things here that need to be swapped. Is that right? Yeah, XORing these 2 things. Oh, no. This has to then be XORed with the carry. And the carry is the output of the OR. So at some point, PJG gets XORed with the OR. These are hard problems to keep in your brain. That's what I'll say about that. But I know this is wrong. Actually, I mean, yeah, so then we know Z23 is wrong. Guaranteed, 100% has to be wrong. I could write more code to try and verify. Write this to PFS. So PFS should go into an OR gate. It does go into an OR gate. And then CRQ also goes in the OR gate. So CRQ should come from an AND gate. Okay, and that AND gate should come from a carry. GDQ, which is right up here. Cool, so this comes from a carry. And it also comes from KMW, which should come from an XOR. KMW comes from an XOR. This goes directly into an AND, so this is the carry going into this AND and PJG. So this should be going into an OR gate. I guess the easiest way to kind of verify now is every chunk of 5 should have 2 XORs, 2 ANDs, and an OR. Yeah, look at this. This one has 3 XORs. And it's missing an AND. So there's going to be another one that has 3 ANDs, which I think was the one I was looking at, right? Yeah, so 38 has 3 ANDs. 39 has 3 XORs. Okay, so 38 and 39 are going to be another issue. They XOR to here. They XOR to here. Oh, that one's right. These two XOR into WTF. WTF XORs with Robert Downey Jr. into Z39. This sounds kind. Where's Robert Downey Jr. defined? Because this should come directly from the carry from the last one, so this should be up here somewhere. Yeah, it's an OR. That's fine. Or from FSB or PMD. They're both down here. Yeah, this is wrong. Yeah, look at 37. What's happening here? You should have an AND for before and an XOR for current. XOR for current, AND for before, and AND for before. Well, they're just duplicated. That's interesting. Oh, was it my scroll being weird? Oh my god, it was actually my scroll being weird? Oh, that's super annoying. I put in a little goose chase there. So why are there 3 ANDs here? XOR these number together and write them to Z38. I AND the 2 inputs together. No. We should be XORing the 2 inputs together. Where do we XOR 38? Here we go. This one should be writing to CGH. PMD and CDH, I think, are wrong. PMD, CDH. Did I not copy that one right? Oh, crap. I may have just broke some stuff. Hopefully not. Okay, I think we're good. CGH, is that what I meant to say? It might have been what I was meaning to say. Yeah, I think it's CGH, yeah. PMD and CGH. I should write a tool to swap them. That looks better. 4 XORs and 3 ANDs. So the last one was it's up here a little bit. Where was it? Z23. There it is. There's our 3 ANDs and our 3 XORs. So in order to create Z23, we AND things together. That is incorrect. We should be XORing things together to create them. And we should be XORing this one. That's it. FRT and Z23. I just need to step away from it. FRT and Z23. So now, can we pipe that into part 2? The final is this number. Is that correct? I mean, I don't know if that was... This feels like playing three-dimensional chess. I don't know what this feels like. This feels bad. So if we did this one right... If we did this one right, we should be able to calculate what we just added up, right? Like, if we did this one correctly, we should be able to, I don't know, CP fixed to... foo.text. Vim foo.text. We should just be able to... Because these binary numbers are just what we care about, right? Can I shift J? Can I join with the line above it? J, you know, joins the other way. There's probably some Vim trick to do this, but I have no idea what it is. CP foo to x and x.text. CP foo to y.text. This is so scuffed. Here are my x values. Here are my y values. I'm just creating a binary number in Vim. Don't mind me. It's gone for 30 minutes. What did I miss, chat? I don't even know how to explain it. I think I have it all figured out now. I'm going to test it before I submit an answer. I'm going to test it by figuring out in the real input they gave me what were the numbers for zeros and ones, and I'm going to try and do a full adder on it. So if we do like x equals 0, x equals empty, while read dash r line do x equals line x. No, that puts it at the end. X line. Done. Read in from x. Do the same thing for y. If I did this correctly, we should have x and y. Awesome. Let's make sure I get this right because I always mess this up. If we have x plus $y, it gives us a large decimal number. If we run our full adder against my sorted input, we should get that number. We don't get that number. So I may have, it's possible I messed up these things. I think they're backwards now since each new line is a later bit, so should go first. Isn't that what I did? It's possible I did them backwards. You're right. You're right. You're right. Why did I bother doing this? I just concatenated them. I tried so hard not to get it backwards. I really did. If I did this... Yeah, then I'm not concatenating them. That's what I want to avoid. I think you're right. Oh my god. Oh my god. Our full adder works. Even running it through my magical sorter. So if we run our fixed output through part 2, we get that magical number. Even if we run it through my little sorter. That's so cool that this was I'm glad I came up with this idea. We get the same output. Yeah, this sorted data is way easier to read. Oh my god. So, that means these were the things we fixed. All we have to do now, I wish I could do this in code, but I don't know how to do that. We just have to sort them ourselves. So CDH, PMD, Z23, FRT, SPS, Z11, Z05, TST, highlight them all, colon sort, they're sorted. Now we just have to join them on commas. I think it's join them with commas, yeah. There we go. That Z11 doesn't go there. Remove the spaces, and we're good. How did he fix visually? Exactly that. I don't know what part of the stream you missed, but I'll show you. I took the real input, which was this, and I ran it through a program that I wrote called Sorter. Sorter used a depth-first search of all of the outputs that were being generated, and it figured out which outputs were related, and I commented them. So I updated my code to handle comments, so I could see that in order for Z00 to be set, we needed this to happen. In order for Z01, we needed this to happen. And a proper full adder machine has 5 gates, 2 XORs, 2 ANDs, and 1 OR. So by scrolling visually, you can see, uh-oh, something's wrong here. Uh-oh, something's wrong here. Probably related, don't necessarily have to be. Got lucky that they were. Uh-oh, there's more than 5 here. This one has XOR, XOR, XOR. That's not right. So that's kind of how I did it. Literally just a visual inspection. I don't know how I would approach this in code. You could write code that drilled into problems like this. Like, oh, we know that Z23 has a problem, Z25. We could find all the problem numbers and then try to randomly swap things until we get an answer that works. Brute force, but cut down the domain that we have to search for. Possible, but I don't know if there's a more elegant math solution to this. There probably is. Look at this one. This one had 1 XOR and 3 ANDs. And then down here we can see we have 3 XORs and 1 AND. So that it was all visual. So if we go over here, what are we doing? Where did I write it to? BOGO sort type of solution. Exactly, you understand. So here are the things that we swapped to make it work. In the format they want, sorted, separated by commas. I'd be so curious to see, like, this is one of those puzzles where I feel like generating the puzzle would actually be fairly easy. You start with a working full adder and then just arbitrarily swap a couple of them. You ready? That's not the right answer. How is that not the right answer? Is it CDH or CGH? Oh! Thank you. Thank you. CGH, not CDH. What do you think the cooldown is on me submitting it? All right, that last account didn't happen. That last attempt doesn't count. First time, let's see if we get it. First time, you ready? It might yell at me. It might be on cooldown. 23 seconds left. Just because of a typo. CGH. CGH. That's so funny. I was waiting. I was about to ask if you wanted to know what you did wrong. I've been waiting since you updated the fix.txt, but not your notes. That's really funny. I don't envy your position. I know what it's like when I'm watching someone like code or even do anything and they make like what's clearly an obvious mistake, but the kind of mistake that'll cascade nasty. And it's like, I kind of want to tell them, but it's also kind of a fun learning experience. But yeah, I appreciate that. What do you guys think? 23 seconds have elapsed? Let's go. Let's go. Let's go. That's the right answer. That's the right answer. You are 1 gold star closer to finding the chief historian. Heck yeah. That's right. That's right. I lifted up my arms. I could smell my armpits and how sweaty they were. I am disgusting. That was grotesque. Oh, I feel the need to apologize for you guys, even though you can't smell it. Oh, I need to... Oh, put them down. What am I thinking? I need to take a shower badly. Oh. And I'm not like a weird nerd that doesn't shower. I shower once, sometimes twice a day. But, oh, man, I don't know. I got sweaty. Did a workout today. Haven't showered after it. So, yeah, I need it. Oh, man. We got it. We got it. How beautiful. I messed with that W. Heck yeah. Nicely done. Yo, appreciate it. Appreciate it. Here's my working out for figuring out the gate pattern. Ooh, I'll check that out. We got it. We got it there. Let's see. I'll pull it up on stream. Let me just catch up on chat. You didn't need to fully fix it. Just identify the wrong wires so you could programmatically find wires that wrong, not necessarily where they needed to go. Yeah, I think I could definitely do that. And I know some tricks too. Like we know what a full adder looks like, so we can start to calculate what should be there. Well done. Did the same. Write a validator and then visually rearrange. That's the way to do it. I mean, that's the way I did it. That's the way we did it. Thank you for the $5 super chat. Yo, Andre comes in clutch. Every time I get one of these puzzles down, I get a $5 super chat. I have found the unlimited money glitch. It's incredible. Thank you, Andre. That's super cool.